Okay, so now we are going to talk about psychophysical method to manipulate attention. To understand the relationship between the consciousness and attention, it would be nice to keep unrelated components unchanged. This unrelated component obviously includes this eye movements that we discussed, but also keeping the stimulus same is also ideal because we don't want to conflate the stimulus difference with the difference in attention or consciousness. So bottom-up attention in that sense is by definition stimulus driven. So attentional manipulation also involves stimulus manipulation. So it's not super easy to understand what the attention and consciousness relationship is. So, but if you want to use the bottom-up attention type stimulus or paradigm, then what we can do is to manipulate these kind of factors and then study how attention consciousness relationship change as a function of the stimulus, or how the eye movements are consciously or unconsciously guided by the stimulus. And we are going to talk about this type of the studies next week. And then the first types of the stimulus that I'm going to talk is change blindness. So I guess some of you might have seen this change detection or change blindness paradigm, but I'll just show it nonetheless. You're about to see two images switching back and forth in rapid succession. And then your task is to spot the difference between them. Okay. Keep your gaze fixed on the center. And then if you can see the difference, then press the button or whatever. Okay. And then watch it again with the benefit of a covert shift of attention. Pay attention to the trousers worn by the man on the far left. As before, keep the gaze center. So this means that the covert shift of attention is there. And then now you can probably see the difference goes to blue to brown. Okay. And then another one, keeping your eyes focused on the center. Don't move your eyes. And then can you see the difference? And then according to this, it says that none of the students in the class can find it. And then the car window on the right, you pay attention covertly, and then still look at the center of display, like here, okay, in the pointer. And then this is going to be again another discussion. And then here, just focus at the center. And then if you see attention, if you pay attention to the background behind the Jackson, $20, then you'll probably see it changing from black to white. Okay, so this is the change blindness demo. All right, then the next demo is inattentional blindness. So pay attention to this, 3 out of 6 peoples, and then especially the white team, and then count the number of the passes. Okay. Okay, so that's the demonstration of the change blindness. And And here is the demonstration of the attentional blink. So, but by attention blink, it means that your attention seems to momentarily blink, or as if I blink, and this is a demonstration. And throughout this demonstration, you basically try to find stimulus. Okay, stream of the letter will appear. It's very, very rapid, so you just need to focus there, and then try to find R. Okay, if you find R, then you just press the button, kind of thing. But right after R, if you see C, the letter C, then you're not attentionally blinking. But if you after trying to see R, if you cannot see C, then that's the erasing the next target, meaning the attentionally blink. Okay. So here it says that consciously noticing R or C in its own is not too difficult, but doing both is difficult. Okay. Here they come. Try to find R. Yep. Okay, I think you might have seen this again, but if the display speed is not right for the Zoom, then please go to this website again by yourself, and then do the same thing. At least on YouTube, it should work. All right, then finally, there is this dual task paradigm for attention. Here, simply saying the attention is assumed to be a fixed resource kind of things, and then the benefit of attention is quantified by whether you can actually do two things at the same time. So it's a multitasking kind of situation. And the series of the experiment has shown that if you do something extremely difficult, like here, it's a 5 letters of rotated T's and L's, and then if you're asked to say that if all of the 5 letters are either T's or L's, versus one of them is L's, like this one, versus 4 letters, 4 T's, or 1 T versus 4 L's, this turns out to be very, very difficult, especially if it's masked at the end by a rotated F. And this is known to be incompatible or difficult to do with a similar kind of attention demanding task at the same time. On the other hand, when you pair this central letter task together with some other stimulus, such as in this case, it's a natural scene, and then ask people to say whether that natural scene photograph contained either animals or not, then that can then test whether attention is necessary to do this task by comparing the performance of this natural scene task while you are doing this central task and natural scene task, or natural scene task alone. So it's a contrast between dual central and peripheral task versus single situation where you do only the peripheral task. And then if this and this performance is more or less the same, then that means that the exhausting attention by the central task does not affect on the peripheral task, meaning the peripheral task does not require attention. So that's the logic of this dual task. Okay, and then I'll just show you the demo for this dual task. And as this scheme shows that it's going to be very, very quick kind of task. The central task will be masked by stimulus onset asynchrony, and also peripheral task is also masked by peripheral SOA. And then both of them are matched to make the both of the tasks demanding when you do it on its own. Okay, so here is how it looks like. So first, let's do the central task only. Okay, so focus here, and then say whether all of the letters are similar, same letters or not. That's the same all T's. That's all L's. That's 1L and 4T. That's 1T and 4L's and so on. So that's the central task, okay? And then now, without moving your eyes from here, do the task again, but on the periphery. Yeah. And then say it was an animal or not, okay? And that was flower, that was natural scene, rocks, and that's a lion, and that's beetles, and so on. And then finally, under the dual task situation, you do the both here. Okay, so that's L and then lion. That's T and beetle. That's all T and flower. That's L and then rock. That's a kind of the dual task situation. Okay, let's go. And the point of this task is, in fact, you can do the natural scene task recognition with together with the central task without much impairment in performance. The next demonstration is this red-green disk situation. So again, central task is the same LT disk, LT discrimination, but peripheral is now the discrimination of left or right side of the dot. The disk is green. Okay, so let's focus on the center and then say which one is red. So now I saw it on the left side is red. Okay, the next trial. Okay, again, left side was red. Don't move your eyes from center, okay? Right side was red. Okay. The right side was red, and so on. So here, if you try to do the central task together with peripheral task, now if you do it, if you try to do it, then what happens? Okay. T and 4L's, but I wasn't sure. 4L's and probably right side of L's. All T's and not sure. So this is a kind of the task that you can probably do both tasks at the same time. But again, we need to quantify and modulate the difficulty of the task individually. So this doesn't work. By the way, these are the response screen that actual subject is going to press on the screen in our experiment. So the left side is the same and the right side is this different for the letter task. And then here it's the red green and green red disk option is presented, and the confidence rating is clicked from 4 for sure and then 1 for not sure, and then 1 click can give a response for 1 task. Okay, that's a dual task. Next, the same dual task, but now the peripheral stimulus becomes now face discrimination, and your face discrimination task is going to be about the gender discrimination, male or female. And then this time, I'll try to do central task and the periphery at the same time. Okay, here we go. So the next one is the task, all L's and then female. One L and the female. All L and the female. One T and male, probably. Something like this. So I probably made a mistake on the second trial, but roughly speaking, this face task is known to be possible even if you are paired with the difficult central task. That's the conclusion on the dual task. Okay. So the way to quantify this dual task is to first, quantify the central letter task performance to be, located here. And typically, this is a normalized version, but on average, people tend to use like 70% or 80% accuracy of the difficulty. And then the peripheral performance is also set to be 80% accuracy, very difficult. And then when you do the central only or peripheral only, it's 70 or 80%. But if you do both at the same time, for example, this dot corresponds to that the task is peripheral task is around 90% of the 70%. So that means 63% of the peripheral performance together with 90% of the peripheral. So that's a 72% accuracy, and so on. And then if you do it multiple times, it locates to this top corner more or less, meaning that there is a little bit of, if anything, the degradation of performance here. And then here is that task is animal versus non-animal. And if you do the same thing with the animal versus distractor, including the city scene or vehicle, the conclusion is the same. You can do it without much cost. And then if you suspect that the animal is really the special kind of the thing, and then you can do the experiment again using the same set of the stimulus as B, but now change the target to be vehicle. But again, you don't see much difference in terms of the performance. On the other hand, if you do this dual task with green-red disk like this versus this, then almost always performance is located along this diagonal. What it means is that if you try to prioritize the central letter task, then your task performance for the peripheral green-red becomes chance performance. On the other hand, if you try to keep your performance of the periphery at the normal performance, then your letter task at the center becomes chance. And then if you try to do both, then your task is always almost like a trade-off between them. So the height or sort of this distance between this diagonal line to the average performance here is a measure of the attentional requirements for the peripheral task. This requires attention. That's the reason why your performance aligns here. And natural scene stimulus or male-female discrimination tend to locate here, meaning that it doesn't require attention. So in summary, I just briefly described a couple of attentional manipulation paradigms. And then there are many paradigms available to manipulate various aspects of attention. And the various aspects are the ones that I reviewed in the first part of this video. And then to study the relationship between attention and the consciousness, keeping the stimulus or consciousness or behavior is always ideal. And in that sense, manipulation of the bottom-up attention is always difficult to interpret. So you need to be careful. But promising manipulation of the top-down attention includes, so here you don't change the stimulus input, okay? But you just change the covert shift of attention, like let's say in the case of the dual task, you always look at the center, but you change the attentional location. And the change blindness was also like that. Inattentional blindness was also like that. And then just change attention through the instruction or expectation. And the change direction and change blindness and attention, inattentional blindness are also involved in this expectation. Okay. On the other hand, so this means that the key paradigm in the future are likely to be the change or inattention blindness and how it actually interacts with other factors of the consciousness or visibility. So this is mostly the spatial attention or expectation component or crowding that we will be talking next week. And then attention blink and backward masking is kind of related, and it's a relationship between the attention and the consciousness in the temporal domain. And then the dual task. And how much, so now we have actually learned these types of the manipulation of attention and how it can potentially affect on the consciousness. We need to go into a little bit deeper on how much do we know about the neural mechanism of attention, and with what we know so far, I mean, in science of attention, how much we can actually explain these types of the attention and the consciousness phenomenology. And that's the next part of the video.